Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video session, I am going to discuss about the losses in DC machine. Okay, so here in today's session, we are going to discuss about the losses in a DC machine, right? So here basically the losses are classified into three types. So first one is copper losses, and second one is iron losses, and third one is mechanical losses. Okay, so here the losses are classified into three types. So first one is copper losses, and second one is iron losses, and third one is mechanical losses. These are the three different types of the losses which are occurred in DC machine. If it is a motor or if it is a generator, the losses are same only. Okay, so here the losses which are classified into three types. So in that, first one is copper losses. So this copper losses, we can also call it as a I square R losses. This copper losses, we can also call it as a I square R losses. Okay, so now what is meant by copper losses? So copper losses are nothing but the power wasted in the form of I square R losses, and these type of losses are occurred at windings of a DC machine. Okay, so here copper losses are nothing but the power wasted in the form of I square R losses, and these type of losses are occurred at windings of a DC machine, right? So basically in DC machine, we are having the armature winding and series field winding and shunt field winding. For the armature winding, we are having the armature resistance, and series field winding we are having the series field resistance, and shunt field winding we are having the shunt field resistance, right? So now at armature resistance, the copper losses is represented as in terms of I square R. The copper losses we have to represent in the form of I square R, right? So now at armature resistance, the copper losses is IA square into RA. At armature resistance, the copper losses IA square RA. At series field winding, having the series field resistance, the power losses is represented as a ISC square into RSC, and for the shunt field winding, having the shunt field resistance, and the copper losses is represented as a ISH square into RSH, right? So these are the copper losses which are occurred at windings of a DC machine. Okay, so now the total copper losses equal to sum of these three, that is IA square RA plus ISC square into RSC plus ISH square into RSH. Okay, here is the total copper losses in a DC machine. First type, that is copper losses, and the second type is iron losses. So iron losses we can also call it as a core losses. So what is meant by iron losses? So iron losses are nothing but the losses which are occurred at core of the DC machine. We can call it as a iron losses. So these type of iron losses having the hysteresis losses and eddy current losses. The losses which are having the hysteresis losses and eddy current losses. So these are the two types of the losses of iron losses. So iron loss are nothing but the losses which are occurred at core of the DC machine, we can call it as a iron losses. So these type of iron losses includes hysteresis losses and eddy current losses. Okay, here is the iron losses. And the third type is mechanical losses. So here the mechanical losses which are occurred at shaft of the DC machine. Mechanical losses which are occurred at shaft of the DC machine, we can call it as a mechanical losses. So these type of mechanical losses includes friction losses, and windage losses. These are about the mechanical losses. So mechanical losses are nothing but the losses which are occurred at shaft of the DC machine and which is having the friction losses and windage losses. So these are the three different types of the losses in a DC machine. Now total losses. The total losses is equal to, so the unit of the losses is watts, that is copper losses plus iron losses plus mechanical losses. Here is the total losses in a DC machine. So total losses in a DC machine is equal to copper losses plus iron losses plus mechanical losses. Okay, these are the different types of the losses which are occurred at the DC machine. Okay, so now we'll discuss the one problem on the losses in a DC machine, right? So here we are having the shunt type generator. So shunt generator. So first we have to draw the shunt generator here. So this is the shunt type generator. So plus minus, generator means we have to give the load. So here we are having the load. So this is generator having the generated voltage, armature resistance, shunt field resistance and load. At load we are having the terminal voltage is Vt and current through RA is IA, current through RSH is ISH, current through RL is IL. Now a shunt generator delivers 195 ampere, 240 ohms. Means for the shunt type generator the load current is given. So 195 ampere load current is given. So write the data here. So load current IL equal to 195 ampere at 250 volt terminal voltage is there. That is Vt equal to 250 volts. The armature resistance and shunt field resistances are 0.02. Means armature resistance RA equal to 0.02 ohm and shunt field resistance RSH equal to 50 ohm respectively. And iron and friction losses. Iron and frictional losses equal to 950 watts. Means iron losses and mechanical losses are given. Iron losses plus mechanical losses. So these two are given. That is equal to 950 watts. Now we have to find out the EMF generated. Right? Now we have to find out the EG value. So first bit is we have to calculate the generated EMF, that is EG, equal to VT plus IA RA, right? So now we have to calculate the terminal voltage is there, VT. So VT equal to 250 volts and RA also is there, that is 0.02. Now we have to find out IA here. So from this diagram, IA is equal to ISH plus IL. So here IA equal to ISH plus IL. So load current is there, 195 amperes. ISH, we don't know ISH value. Now we have to find out the ISH. So where ISH equal to VT divided by RSH is the equation. That is equal to, what is VT? 250 divided by RSH. So RSH is nothing but 50. So here we'll get 5 amperes. So 0 0 get cancelled, 5 5s, 5 amperes ISH. Therefore armature current IA equal to ISH. ISH is 5 plus IL value, load current value is 195, that is equal to 200 amperes is the armature current. Okay, we'll get IA equal to 200 amperes. Now find out EG. So therefore EG equal to, so VT, what is VT? 250 plus IA 200 into RA 0.02, that is equal to, we'll get 254 volts is the generated voltage of the given shunt generator. Here is the first bit. Next, second bit is we have to find out the copper losses. We have to calculate the copper losses. So the copper losses equation is, so this is shunt type generator. In this shunt type generator, we are having the armature winding and shunt field winding. That means the equations are IA square RA is the one equation, another equation is ISH square into RSH. So we have to write like this, IA square RA plus ISH square into RSH is the equation. So that is equal to, so IA 200, so 200 whole square into RA. So RA value is 0.02 plus ISH value. ISH is 5 amperes, means 5 square into RSH is 50. So now by solving this equation, we'll get some 818 watts. Here is the copper losses of the shunt generator, right? And CVT is output power. So here output power equal to, so output means across the load. So output power is equal to, so V into I, that is equal to, what is V? 250 into I is, that is IL 195. So V into IL, that is equal to, we'll get 48750 watts. So output power. And dBit is efficiency. So efficiency means we have to find out the efficiency, that is dBit, the percentage efficiency. So efficiency is defined as, it is the ratio of the output power and input power. So here P output divided by P input into 100. So now already we are having the output power, that is 48750 watts. Output power is there. Now we have to find out the input power. So input power is equal to, we are having the equation, input power equal to output power plus losses. That equal to, what is output power? 48750. 48750 plus losses are nothing but iron losses plus copper losses plus mechanical losses. So here iron losses and mechanical losses are 950 plus copper losses are 818. Now by solving this equation, so 48750 plus 950 plus 818 will get 50,518 watts. Will get the input power. Now substitute the output power and input power in this efficiency equation. Therefore, the percentage efficiency equal to output power 48750 divided by input power 50,518 into 100. That is equal to, will get 96.49% of the efficiency of the DC shunt generator. Here is the one problem on the losses in a DC machine. Okay. So thank you one and all.